dear students.
Frame 1, but this frame 1 is lost. So in that case, and the sender don't know that frame 1 is lost, as because the timer is on, and if the time is out, then sender will understand that yes, that we can't get the acknowledgement from the receiver, that means the frame is lost. Then sender can understand, but before that sender don't know about this incident. So sender will send the data again and again. So sender send frame 2, frame 3, okay, in this way sender sending all these things. So, but all these frames sender is sending, that means these frames are occupying the channels, and it takes the time also. The arrival time is also there, and the channel is also busy because of these frames, but the receiver did not receive these frames, because receiver is this is a window concept, and receiver only have a single window concept. So window size of receiver is 1. So now receiver is wants to accept frame 1, because this is a red zone, this is 1. Frame 1 is now the receiver will expected, but frame 2 is arrival to him. In that case, receiver can't accept this thing, so no action, nothing is happening here. So the frame is there, but it is not received. Similarly, frame 3 is also travel the channel and also reach to the receiver, but receiver did not receive it. So what happened after time out, then the acknowledgements are not received by the sender. So then sender understand that yes, there are some problems, maybe some data lost, so I need to resend the whole frame. So then what the sender can do? Sender can do all those frames from frame 1 to the last frame. Okay, so frame 1, frame 2, frame 3, again these all frames are sending. So that name is go back in, as because the n is actually the frame number which is actually lost. So we need to go back to that frame, and we need to resend all those frames after that, including that damaged frame also. So that is, so this go back in ARQ has a big disadvantage that it takes much more time to send all those frames. Okay, and it will means time consuming also, and channel is also occupied by those frames also. So it these type of things are problematic. So we can switch from the next algorithm, that is selective repeat ARQ. That means we need to select the particular frame which is actually damaged frame. Okay, so here you are sending the data. So in selective repeat ARQ, see, in selective repeat ARQ we have a we have a special thing, that is NAC. Okay, that means when the data is not received by the receiver, then this not acknowledgement frame must be sent by the receiver to the sender. Okay, these things is not not there in the previous algorithm, because when the data is not accepted, then it should be the not acknowledgement should be sent to the sender. So sender will be alert that yes, this frame is lost, then I need to resend this frame. Okay, so in selective repeat ARQ, the name is selective, as because you need to select the particular frame, the damaged frame, what is lost here. So this damaged frame you need to select, and then just resend that frame. So now you can see that frame 1 is lost, but sender don't know about that. The frame 1 is lost, it is not received yet, it is not arrived to the receiver. So now sender sending frame 2, but this frame is frame 2 is there, but this is means it is not received by the receiver, it is arrived, but it is not received because Rn is this. See, Rn is this, Rn is mentioning 1, that means Rn wants to accept frame 1. Okay, receiver wants to accept frame 1. So this is the frame what receiver wants to, but the frame 2 is sending by the sender. So receiver will send this not acknowledgement NAK. Okay, so this NAK signal must be sent to the sender that this frame is not accepted. So then what will happen? Then frame 2 is actually arrived, frame 3 is also arrived, this is also arrived, and then what, when the NAK is this NAK 1, see one thing, this is NAK 1. NAK 1 means what? NAK 1 means it is the not acknowledgement of frame 1. Okay, NAK 1. When I am saying ACK 1 means receiver wants this frame 1. Receiver wants to receive frame 1. But when I am saying NAK 1, that means the frame 1 is lost. So this NAK 1 is sending. This NAK is actually received by the, when this NAK is received by the receiver, at that moment sender need to resend the frame 1. See, when this NAK is received by the sender, then sender resent this frame 1, and then all those acknowledgements, all the other frames also be received by the receiver, frame 2, frame 3, frame 4. So it is passing the acknowledgement 4. Okay, that means 1, 2, 3 is received. Then ACK 4 means receiver wants to receive frame number 4. Okay, that means frames 1, 2, 3 is delivered, and now send me the 4th frame. Okay, so this is the thing. So here you can see the window size is not single, but in the go back in. Okay, so now the frame type, if the frame type is equal to NAK, then you have to check whether the not acknowledgement number in between first frame and the next frame to be sent. Okay, if it is true, okay, then resend that NAK number, resend that frame. Okay, so NAK number means resend that frame. Then start timer again, start timer NAK number. So from there you need to start the timer also. Then that means if you are sending the frame again, so you need to wait for the acknowledgement also. So you need to start the timer again. Okay, so after resending the frame number, you need to start the timer. Okay, so and if this frame type is ACK, then and you have to check whether acknowledgement number is in between SF and SN, then it should be SF less than ACK number. Checked whether SF less than ACK number or not. Okay, if it is less than, then purge SF. That means that first frame is actually received by the receiver, and you need to just discard that frame from your buffer, because each and every frame what you are sending, you are just keeping a copy of that frame, no? So you can just remove that frame from that buffer. Okay, and after that you need to stop the timer and again increase the frame number, SF equal to SF plus 1. Okay, so in this way sender can send the frame. So this is the sender side algorithm, and again finally if the timer expires, then you need to start the timer again and send the frame again. Okay, if the timer expires and you cannot get any values, means you cannot receive the acknowledgement from the receiver, then you need to start the timer again and you need to send the frame again. Okay, so this is the whole process for sender side selective repeat algorithm. And at the receiver side selective repeat algorithm, what is going on, that is receiver Rn is equal to 0. At first the window number, the frame the receiver wants to, that is 0, and NAK sent is equal to false, and acknowledgement needed is equal to false. So at first all these values are false, because the receiver is not received any frame, so the NAK and acknowledgement frame, all these values are false. And after that repeat for all slots, you need to repeat for each and every frames. So marked slot, you need to mark that slot. Slot means in the at the window you need to mark that which frames is now accepted. Okay, so here you can see the value, that is the red mark. If the frame 2 is arrived, this is red mark, but Rn is 1, Rn is not incrementing. See, Rn is the 1 because number 1 this frame is expecting, but it is not received. So this, if frame 2 is received is arrived, then you can mark here. If 3 is arrived, then yes, it is arrived, but you cannot means it can store here, but it is not received. It is in this window, so it is arrived. This is arrival notifications, that this value is arrived. When this frame 1 is actually accepted by the receiver, then only all the values should be accepted. Okay, so when any frames is received, then there should be a marked. So marked slot, at first marked slot equal to false, so all the values at first false. So these are some flag values what receiver in the receiver side algorithm we need these flag values. Okay, so Rn, NAC sent, acknowledgement needed, these things. Now while true, while this value is true, then what is happening, that is this loop is repeating forever. So wait for event, we have to wait for event, and if event arrival notifications is true, then receive frame needs to be received, frame will be received by the receiver. If the frame is corrupted or not NAC sent, okay, not NAC sent, that means now NAC sent is equal to true, NAC sent is equal to false initially. So if not NAC sent, that means this value is true. Okay, so that means this is not received. When the frame is not received by the receiver, then only NAC is generating, no? It will be generated. So and if it is true, if NAC sent is equal to true and corrupted, frame is corrupted, that's why you are sending the not acknowledgement to the sender. So if these two things are true, then send NAC Rn. Okay, then that frame number you need to send as a NAC. So and NAC sent, make NAC sent is equal to true. Okay, and sleep. And sleep means you have to wait for that frame. The receiver needs to wait for that frame. So sleep. If sequence number not equal to Rn, if sequence number not equal to Rn and not NAC sent, then what will happen? Sequence number is not equal to Rn and not NAC sent. That means NAC is also true. Okay, that means the number what the receiver wants to, that is the sequence number what the sequence number, that means this number is sending, this number is sending by the sender, sequence number. Suppose when frame 1 is not received, but frame 2 is sending by the sender, then sequence number is 2, but Rn is equal to what? Rn is equal to 1. So this value should be 2 and this value should be 1, because Rn according to our flow diagram, this Rn is actually wants frame 1, but it received sequence number 2. So this number is mismatched. Okay, so in that case, and not NAC sent, this value is also true. Then also the receiver can send the NAC. So there are two conditions from this when these two conditions are will be arise, then receiver needs to send NAC. Okay, so number 1, if the frame is corrupted and then NAC can be generated. Another thing, if the sequence number what the Rn is actually what the number Rn have, and that number is actually what, that is the expecting frame by the receiver, and the sender frame number is also different. So if the two numbers are different, then also NAC can be sent by the receiver. So in this two case, receiver can send the NAC. And again, if NAC sent equal, then NAC sent equal to true. And after that, if sequence number in window, sequence number present in that window and not marked, the sequence number is already not marked. Okay, sequence number is there inside the window, but it is not marked sequence number, then store the frame. sequence number, and mark sequence number is equal to true, like this red mark. This sequence number is this is mismatch, but this frame 2, this number 2 is also in this window, so this 2 can be inside the frame can be stored here, frame can be stored inside the window, it can be stored. That's why second time, at the second time when the frame 1 is actually passing, this frame 2, frame 3, it is not required to send again, because this 2, 3 is restored inside the window. Okay, so that's why sender needs to send only frame 1, not other frames. Okay, so that's why this is selective repeat ARQ. We are here we are getting the advantage on go back in ARQ, because all the frames, because the window size is same as the sender, so sender can, whatever sender can sending, that value can restore here, it can store here. Okay, maybe receiver wants frame 1, but frame 2 and frame 3 can stay inside the receiver. Okay, so that's why in this algorithm this is saying that if the sequence number in window and it is not marked, number is not marked, then store the frame sequence number, you can store the frame, then mark the frame. Okay, and while marked RN, when it is marked, when you are marking it, that means you are delivered data is delivered there, and purge RN, then you can purge RN. Purge RN means the window can be shipped, okay, to the next RN, next frame need to receive, so it can shift. And so RN equal to RN plus 1, and acknowledgement needed is equal to true. Then acknowledgement, you can send, the receiver can send the acknowledgement. So if acknowledgement needed, then send acknowledgement, and after sending the acknowledgement needed needs to false, and NAC sent, it also needs to false. Okay, so this flag value after sending acknowledgement, this value should be false, acknowledgement needed, it will be false, and also NAC sent also will be false. Okay, so this is the receiver side algorithm. So this is the delivery of data in selective repeat ARQ. So before delivery, and acknowledgement number sent 3 after delivery. So we are passing the value 0, this is 0 is the RN. Okay, so 0 window size is actually this is 3 bit, we are talking about 3 bit, that means 2 to the power 3, that means 8 values can be stored in the window. So 0, 1, 2, 3, 4, 5, 6, 7, so 8 bits, 8 frames, 8 values can be there, 8 bits can be there. And here we are sending 0, 1, 2, these values are also received by the receiver, and acknowledgement number sent 3, that means now this 0, 1, 2, when this yellow lines, these are already received, and this is the acknowledgement is also passed. And now after delivery, if this 0, 1, 2 is means delivered, that acknowledgement is delivered, then window should be shipped to the next locations, that is from 3. So 3, 4, 5, 6, 7. So after delivery we are getting these things, and acknowledgement number is 3, that means receiver wants to receive third frame. Okay, so acknowledgement, remember it, acknowledgement number indicates the frame what the receiver needs to accept, and NAC number indicates what frame is not received by the receiver. Okay, that frame is not received by the receiver, and receiver wants to accept that frame. So when there is NAC, when a sender is getting any NAC value, at that moment sender needs to send that value. Okay, if there is acknowledgement and NAC both are there, so at first sender needs to send the NAC, not ACK. Okay, which NAC means what? NAC means already that value you are passing, you are sent before. Okay, and that is not received by the receiver, so immediately sender needs to send that value. Okay, So here in this example, we are getting the example that okay, in which frame 1 is lost in this flow diagram. So here this frame 1 is lost, okay, and so we show how selective repeat behaves in this case. So one main difference is the number of timers. So here we see, you can see that different timers are here. So at first, see, this is the initial number. So SF SN is indicating the first value. So frame 0 is accepted. 0 is accepted. When 0 is accepted, then acknowledgement is received by the receiver. When this acknowledgement is received, then the timer should be off. See, here is the small timer. So timer is off here, and the window should be shipped here, and for receiving window also, receiving window can shift to the next locations. And after that, here when the next frame, that is frame 1, is wants to sent by the sender, then the timer is on again. Okay, so timer is on. Then frame 2, frame 3, these values are actually arrived, and it can store into the receiver. It is storing here, and when the acknowledgement NAC is received by the receiver, then timer must be off, because you need to on the timer again, because see, for each and every frame there is a timer. See, for frame 2 there is a timer, for frame 3 there is a timer. So we have, for each and every frame we have a timer. Okay, so when we received, so when frame 1 is frame timer is on, and when sender received this NAC 1, that means that time the timer needs to off, because the sender needs to resend the frame. So when you are resending the frame, then you need to start the timer again. So there is another timer also. This is the time period. Okay, so frame 1 is resent, and when sender received acknowledgement 4, that means ACK 4, then that means what? All the frames, previous frames is actually received by the receiver, and receiver wants the 4th frame, and the window see, the window is shipped to the next locations, that is 4, 5, 6, 7, and here also window shift to the next locations. Okay, so this is the selective repeat ARQ. Okay, so here is another concept of networking, that is PG backing. PG backing means what? PG backing means, yeah, here we are means something we are attaching with the frame. PG backing means we are attaching some more informations with the frame. See what we are attaching. So this is our sender window, and this is the receiver window. Okay, and this is the window size. This is the window size. These 4 bits are marked here. Here also in the receiver side the 4 bits are marked here. So this is the same thing that from the network layer, data link layer is getting the data, and it transfer it to the physical layer, and data is passing in this way. See this part. So what the frame is actually getting, that is frame is here, but with this frame we are sending the ACK number as well as the sequence number. Okay, when we are sending a frame, if we already acknowledge, if this is the expected frame by the receiver, that means the acknowledgement number must be here, and the sequence number from the sender end, the sender have the sequence number also. So with this frame, the sender is sending the sequence number as well as acknowledgement number. This is called PG backing. When we are attaching something with the frame, okay, with the corresponding frame, that is called PG backing. That is very important term. And all the other things are the same. So here the request from the network layer, see and then algorithm for sending and receiving, and there is a notifications from physical layers that when any acknowledgement or NAC is this in go back in ARQ we don't have NAC, we only have acknowledgement. So any acknowledgement is received, then it will pass to the from the physical layer, it will pass to the data link layer. And here is also the timer need to send when you are sending any data, and then you need to start the timer. Okay, the same thing happening in the receiving window receiver also. So here the thing is that the sender needs to send the sequence number, acknowledgement, as well as the acknowledgement number. Okay, so here also receiver also send the receiving window number, that is it can send the acknowledgement number as well as the RN number. Okay, what number it has, that RN number and the acknowledgement number. Also these two things must be adjoined with the frame, so that is called digivap.